Partial replicate bioequivalence study is a type of study design for the bioequivalence testing, and this bioequivalence testing study or design is used when the drug shows high variability in the pharmacokinetic parameters, and this high pharmacokinetic variability to assess the intra-subject variability effectively. In this study, the reference formulation is given for 2 times and the test formulation is given for first 1 time. That is total it will become 3, and that's why it is also called as three-way study. It typically involves 3 periods like test, reference and then reference. It is the study design. Each subject receives the test formulation once and the reference formulation for twice. It allows more accurate assessment of intra-subject variability. That means what is the variability of the drug in the pharmacokinetic parameters when the reference formulation is given to the same individual for 2 times. The purpose of study, the partial replicate study, is to evaluate the variability of both test and reference products. It establishes B using scaled bioequivalence criteria for highly variable drugs with intra-subject variability of more than 30%. Regulatory focus for the partial studies. Scaled bioequivalence is used in this type of study, and scaled bioequivalence uses widened acceptance limits for highly variable drugs. It increases likelihood of demonstrating the bioequivalence without compromising the safety and efficacy. If you do the crossover study or standard crossover study for highly variable drugs, it will fail, or generally it may fail because of the highly variable nature of the molecule. The benefit of the partial replicate study is it provides you the robust intra-subject variability assessment, fewer subjects compared to fully replicated designs because it is a three-way study design, and it provides enhanced power to demonstrate equivalence for the highly variable drugs. Data inference in partial replicate studies, intra-subject variability analysis is done. It captures variability for both test and reference formulations, and it is essential for understanding individual responses to the drug. Then scaled bioequivalence, that is SAB, it is applied if coefficient of variation, that is CV, is more than 30%. Then widen the bioequivalence limits. Always know that the bioequivalence limits are widened for the Cmax. Limits are proportionally adjusted based on the reference product variability. You can get more information on this scaled bioequivalence in the playlist of bioequivalence and IVIVC on this channel. Confidence intervals, 90% CI for Cmax and AUC is compared against the standard or scaled B limits, and it determines the acceptance for the bioequivalence. CI limits for Cmax are widened based on the scaled bioequivalence. Detection of outliers. Multiple reference doses help to identify and manage the outliers, and it ensures reliable bioequivalence conclusions. Statistical models are applied like mixed effect models, ANOVA analysis for PK parameter comparison, test versus reference, inter and intra-subject variability quantification, sequence period, and the carryover effects. Then statistical models, mixed effect models, ANOVA are there. Then variability source determination. It helps to identify whether the variability is due to formulation differences, study methodology, or subject specific factors. So understand here that if the reference formulation shows the variability, then you can scale that variability for the test formulation. And that's why there are higher chances for the detection of outliers, for the detection of formulation differences, for the detection of effect of study methodology and the subject specific factors. Regulatory decision making, if the reference product shows high variability, then scaled B ensures inherent variability does not unfairly penalize the test product. This is very important to understand that some study when done in crossover way or crossover design may fail because of the inherent variability of the reference formulation, and that variability can be scaled in the partial replicate, and also it can be done with the full replicate. So successful result from bioequivalence allowing market interchangeability, and applications of these are ideal. It is highly ideal design for the highly variable drugs where traditional design may fail, and it ensures robust and reproducible B conclusion for the regulatory approval. Partial designs are widely accepted for the bioequivalence testing by many of the regulatory authorities. Thank you for watching the video, and let's meet soon with such kind of informative video.